The question says 1 mole of bleaching powder is dissolved in water. This is one chemical reaction. And excess of potassium iodide added in the same chemical reaction. Okay, this is another chemical reaction. And then it says hypo solution required to react with the oxidized part completely. Okay, so first of all we need to write down the chemical reaction and then we can balance it and we answer this question. So one by one we can write down this chemical reaction. First we have CaOCl2. It is an oxidizing agent reacting with water molecule. So what happens exactly? We get calcium hydroxide liberating Cl2 gas. This is one chemical reaction. And in this chemical reaction, excess of potassium iodide is added. When potassium iodide is added in this chemical reaction, it reacts with Cl2 gas. And here halogen exchange chemical reaction is taking place. In place of iodine, Cl will come. In place of Cl, iodine will come. So we get the product KCl, and this is what I2 is there. KCl and I2. Okay. Now from here whatever the product we are getting, from that product, because these reactants converted into product, and from that product hypo solution will start reacting. Okay, so it says hypo solution required to react completely with the oxidized part. So we identify which one is the oxidized part. Okay, so potassium ion is given here. Potassium ion is what? Spectatron +1, iodide ion is here -1. Other side iodine molecule present in 0 oxidation numbers. If you compare the oxidation number of iodine, this is what -1, other side 0. Increase in oxidation number. And increase in oxidation number is always oxidation reaction. Increase in oxidation number is always oxidation reaction. So this is what oxidized part. And when it is undergoing oxidation, completely converting into I2. And this I2 will be reacting with hypo solution. This is the last equation. So let's write down. We have I2 and it is reacting with hypo solution Na2H2 and it is O3 is there. Okay. Now this I2 will of course convert into I minus. Okay, very common. Now pay attention very carefully. If you write the oxidation number of iodine, it is 0, other side is -1. So you can see 0 to -1 decrease in oxidation number, and decrease in oxidation number is always reduction reaction. If this molecule is undergoing reduction reaction, then hypo solution will be undergoing oxidation reaction. Means whatever the oxidation number of sulfur is here, so in the product sulfur is supposed to have higher oxidation number than the oxidation number of the sulfur. There should be increase in the oxidation number of sulfur. And one more thing, this I2 is not a better oxidizing agent. It is an oxidizing agent, that is very clear, but it is not a better oxidizing agent. Because if we talk about the order of oxidizing agent in halogens, so we have fluorine, then chlorine, then bromine, and then iodine. Iodine is coming in the last. Okay, so it is an oxidizing agent, but it is not very strong oxidizing agent. This is the reason it does not convert sulfur into its highest oxidation number. You cannot go for the sulfate ion, sodium sulfate, if you write Na2SO4. No, there will be increase in oxidation number, but there will be minor increase in oxidation number. Why? Because this is a mild oxidizing agent, it is not a strong oxidizing agent. So this is the reason instead of sulfate ion we are getting here, this is what Na2 and this is what S4O6 is there, tetrathiosulfate. Okay, now if you calculate the oxidation number, see how the change in oxidation number is there. This is 0, this is I minus is there. For sulfur we calculate the oxidation numbers. 3 2 is 6, 2 sodium are there, +4, 2 sulfur is equal to +4, 1 sulfur is equal to +2 is there. 1 sulfur present in +2 oxidation number. Other side, 6 2 is 12, -12 is there, and 2 sodium +2, then we got 4 sulfur is equal to 10, sulfur is equal to 10 by 4, 10 by 4 is equal to 5 by 2, 5 by 2 is equal to 2.5. So we got a sulfur present in 2.5 oxidation number. Now you can see there is a minor difference in oxidation number. When there is an increase in oxidation number, that is clear, oxidation reaction is taking place, +2 to +2.5, but you can see it is not reaching 3 also. +2 oxidation number to +2.5. Okay, increase in oxidation number is there. Why? Because this is what mild oxidizing agent. Very interesting. Now we can balance this equation, and always balance the number of atoms. Always balance the number of atoms before balancing the charge. Okay, So we have, you can see 2 iodine other side, 1 iodine multiplied by 2, number of iodine atoms balance. 1 iodine is minus 1, then 2 iodine will be equal to what? Minus 2. Okay, 0 minus 2, find the difference in oxidation number. 0 minus 2, we got 0 minus 2, decrease in oxidation number, and decrease in oxidation number reaction is decrease in oxidation number is always reduction reaction. Find the difference. 0 minus 2 is equal to 2, electron is there. Okay, now in case of hypo solution also, balance the number of atoms. How many sulfur? 2 sulfur. Other side, how many sulfur? 4 sulfur are there, so I multiplied by 2. Okay, 2 to the 4, total 4 sulfur. 1 sulfur is plus 2, then 4 sulfur multiplied by 4 is equal to plus 8 is there. Other side, 1 sulfur is 2.5, then 4 sulfur will be equal to what? Plus 10 oxidation number. Find the difference in oxidation number. You can see plus 8, other side is, it is what? Plus 10, increase in oxidation number, and increase in oxidation number is what? Always oxidation reaction. But what is the difference in oxidation number? 10 minus 8 is equal to 2 electrons. So you can see in both half oxidation as well as half reduction reaction, the transfer of electron is same, 2 electron, 2 electron. So charge is balanced already. Now we can answer this question. What is the question exactly? We have the question, it says that hypo solution required to react with oxidized part completely. You can see. So if you look at the coefficient, here we have 2, and this is what? 1 molecule of iodine. Okay, completely. 2 moles of hypo solutions are reacting with 1 mole of oxidized part completely. So you can see 2 moles of how many hypo solution? How many moles of hypo solution? 2 moles of hypo solutions. You can see we got 2 moles. So here we have the option B is correct. Very interesting question.